So this is Unit 1, Lesson 3. The unit is called Limits and Continuity. The lesson is called Estimating Limit Values from Graphs. What we're going to learn in this video is how to evaluate limits of f of x provided the graph, and what's the difference between evaluating a function at a specific point versus finding the limit as x approaches a specific point. Those sometimes can be the same thing, but quite often they're not. So we're going to unpack that as well. Straight to some examples. Oh, and do me a favor when you see the graph again. I know I can't hear you, but humor me. Just pretend like it's a really scary looking graph and go ooh and ah and like oh there it is. Okay, cool. Thank you for doing that. That makes my life better. All right, so here's a graph of h of x. There's a lot going on here. Starting from the left, we've kind of got this parabolic looking shape until we hit a vertical asymptote of -2. And then after that, we're going to have this cuboid looking shape until we hit another vertical asymptote of 2. Where at 2, we go back up to a hole and work our way down to a hole that x equals 4, where we jump up to a point 4, 5, and work our way back down through a hole, and then our function h of x kind of plateaus, and we find our horizontal asymptote at y equals 2. So if I want to evaluate h of x at the point x equals 6, I'm going to look at this guy, and I have a hole here, but I have a point just above that hole. And so because there's a point right here, we're going to say h of 6 is equal to 4. And so that might take a minute to sink in, but we'll see some more examples of that. So how about as x approaches 6? So if we talk about x approaching something, we're talking about limits. So the limit as x approaches 6 of h of x. So we're going to look at this point as we look at the function h of x from the left as it's moving right towards t equals 6. Not equal to 6, but as it's approaching 6, we reach a limit of 3. From the left, we reach a limit of 3. From the right, as we move left, we see the graph h of x starts moving up towards the point y value of 3, not at 6, but just above 6. As we get closer and closer to 6, we see that we get like 2.9, 2.99. It's getting really close to 3. So because the left side and the right side of the limit are both approaching 3, we're going to say the limit as x approaches 6 of h of x is 3. Okay, now it gets more complicated. Let's look at x equals 4. If we look at the point x equals 4, we have a hole and we have a dot, and the dot is going to tell us that h of 4 is equal to 5. Now if we look at as x approaches 4, we're talking about the limit as x approaches 4 of h of x. And the answer is the limit does not exist. And so why that is because as we approach the limit as x approaches 4 from the left, and so this minus sign right here is think of it as being in the place of the exponent of this 4. It's not an exponent, but we're just going to put a superscript of a minus sign attached to this 4 to say that we're looking at the limit as x approaches 4 from the left. So from the left, we're talking about starting left of t or x equals 4, and we're going to work our way towards x equals 4 on the function line. And as we move from left towards t equals 4, we're going to see the limit on the left side is approaching 2. So the limit as x approaches 4 from the left of h of x equals 2. However, when we look at the right side, if we start at the right and work our way towards x equals 4, we're moving up here, moving up, 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 up. And as we get closer and closer to 4, we see that the limit as x approaches 4 from the right is 5. So the limit as x approaches 4 from the right, this plus sign means from the right, of h of x equals 5. So because the limit from the left and the limit from the right don't equal each other, we say the limit as x approaches 4 does not exist. The left side and the right side have to be equal for the limit to exist as a whole. It's really easy to see that from the graph because we see the left and the right don't meet each other. So that's an issue of continuity we'll unpack later. Okay. Let's look at x equals 2. So at the point 2, we have a hole, but otherwise we have a vertical asymptote. So that if we go down below that hole, we don't have any definition for x equals 2. There's nowhere where our function gives us a value or an h of 2. If we go above the hole, we have the same issue. There's no function up here that tells us how to define h of 2. And the hole doesn't tell us how to define it either. It tells us actually the opposite, that we don't have a definition at this point. So because of that reason, we say that h of 2 is undefined. And so it's kind of similar to a limit of does not exist, but when we talk about specific points and we're evaluating those points, they're either defined or they're undefined. Whereas we're talking about limits either exist or they don't exist. So don't get those two confused. So anyways, as x is approaching 2, we have to look at the left side and the right side again. So as we start left and work our way towards 2, we see this line is getting closer and closer to 2, and then it just drops. And obviously this line will keep going off of our graph window. However, we can assume that it's just going to keep doing the same thing that it's already doing. So as we go from the left, work our way towards x equals 2, we can say that our limit is going to be equal to negative infinity, as in it's just going to keep going down, 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 down. The limit as x approaches 2 from the left of h of x is negative infinity. Now if we look at the right side and work our way backwards towards x equals 2, h of x tells us that we're going to be approaching the value of 4. So the limit as x approaches 2 from the right of h of x is 4. And because the limit of the left side and the right side aren't equal, we say that the limit of x approaches 2 of h of x does not exist. Let's look at x equals 0, the simple example, the one that we hope is going to be on the quiz, right? So at x equals 0, we have a definition, h of 0 equals 3. As x approaches 3 from the left, working our way towards x equals 0, our limit approaches 3. From the right, so we work our way towards 0, limit as x approaches 0 from the right also equals 3. So because the left and the right meet at the same point, 3, we can say that the limit as x approaches 0 of h of x equals 3. Okay, so how about negative 2? There's a vertical asymptote at x equals negative 2. So we have no definition for h of negative 2. h of negative 2 is undefined. As x approaches negative 2 from the left, we have a line that goes straight up. So as x approaches negative 2 from the left, we go to infinity. If we start from the right and work our way towards negative 2, as x approaches negative 2 from the right, also goes to infinity. So because the left and the right are both approaching infinity, we see the limit as x approaches negative 2 of h of x is infinity, which looks a lot like a lazy 8. Like an 8 laying down. We could pick on that 8, but no, he probably had a hard working day. All right, just like we did, because we're in calculus. So now let's talk about infinity a little bit more. So how about the limit as x approaches infinity? So if we look at our function, as x approaches infinity, it would be all the way to the right of the graph. So if we take this function and we extend this window forever, we can assume that the graph is going to continue doing the same thing it's doing, which is continue to just be flat at the value h of as x approaches infinity, we see a limit of 2. So we're going to say the limit as x approaches infinity of h of x is going to equal 2. Now if we look at negative infinity, or as x approaches negative infinity, we're talking about how about if this line continues all the way to the left. And so as we keep going left, 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 even off this graph, we're going to assume that this line is going to continue doing what it's doing. And what it's doing is it's going up, up, and up. And there's no sign that this is ever going to flatten out. And so what we're going to say is as this thing keeps going to the left, it's going to keep going up forever. So the limit as x approaches negative infinity of h of x is infinity. And you can think of this as the x value and the y value a little bit. All right, so here's a bunch of examples. If you wanted to practice a ton of them, here's a bunch of example problems for another function f of x that you can check and work out and see if they make sense to you. Now, I went ahead and crossed off these first 3. So I just want to mention those real quick. F of negative infinity just doesn't make sense. It just doesn't make sense. You can't evaluate negative infinity. You can only evaluate actual numbers, and infinity uh, is a concept and represents a number, but it is not a number. So that doesn't even make sense. Equally as nonsensical, approaching negative infinity from the left doesn't make any sense. You can't get to the left of negative infinity on these x values, because that's like saying you get beyond infinity, which you can't by definition. As you approach from the right, that's kind of like, no duh, of course you're approaching negative infinity from the right. Why would you even say that? So we can just ignore all 3 of these. They just don't make any sense. I'm not going to ask you a question like that on a quiz because it just doesn't make any sense. Unless I said, well, okay, how come this doesn't make sense? But I'm not going to do that. However, the rest of these examples are just worked out. What is the value at that point from the left, from the right, and then what is the limit, or does it not exist? And so feel free to look at these examples, work them out for yourself, make sure you understand them all. So takeaways. So one of the big takeaways from this is for the limit to exist, the limit from the right, as x approaches 3 from the right, for example, has to be equal to the limit as x approaches 3 from the left. So if the limit from the right and the limit from the left aren't equal, then the limit itself does not exist. That's a big takeaway. The other big takeaway we're going to talk about, we talked about in this video, was the limit as x approaches 3 is not always the same as g of 3 itself. Or as we approach our x value, it's not always equal to the x value itself.